my grades are also doing well. So last week we started with osmosis and diffusion, and we tackled diffusion, and we plan to take some experiments on diffusion. And the last week we got to know that diffusion occurs in fluids. So I will need you to give me some examples of fluids that you know. Example of fluid. Last week we did mention of that. That diffusion occurs in fluids. Yes. So we have water. But how many types of fluids do we talk about last week? Water is good. But how many types of fluids do we talk about last week? Two, correct? Until evaporate. Yes. Water and air. Okay, okay. So hot air is given to water. I'm not talking about the solvent and the solute option, but rather we have a general thing for the state of matter that flows. The state of matter that flows. He said water is correct, but we have a general term for that. So liquids and what? Gases. So he said fluids, liquids and what? Gases. So we are going to look at the process of diffusion or the various processes of what? Diffusion. And the first one we are going to look at is the process of diffusion that occurs in the fluid called gases. Hello? So we are going to demonstrate how diffusion occurs in what? In gases. Before that, what is diffusion? We learned that last time. So we are going to use this experiment to get a recap of what we did. What we gifted. If you say, can you hear it? Are you sure? Are you sure you're lying? You are not lying. That's what. Okay, gifted. Until the molecules are evenly distributed. So there is a region of high concentration of molecules, and that concentration will move from that region to another region where there is no concentration or there is low until there is a uniform mixture or until the particles are evenly what? Distributed. So the first one I'm going to demonstrate is what? Diffusion in gases. So our aim of the experiment is an experiment to demonstrate diffusion in gases. So let's check our materials, the things that we are going to use. The materials. So we need what? A spray or a perfume. Let's give a general term, a perfume. Anything that have any scent, that have got a scent, or any scented object or material. And the second one have to get an enclosed area. Example, our classroom. So an enclosed area. What are our procedure? So if you get our enclosed area, the step one of our procedure is that we have to close the enclosed area. And the question is, why do we have to close or get the area closed? Hey, give it to you again. Okay, give it to you. Okay. Yes, any assistance? As I read. Why do you have to close the entire place before ahead? Else, what will pass outside? The perfume, because we have air in the classroom, we have airborne outside. So if you close the windows or the doors, it will evaporate, it will go outside. So first step, so we are going to do that. Close the doors, hello, the doors, and what? The windows of the classroom. Where is the foam duster? Where is the foam duster? So in the end of term exams, I can ask you a question. In demonstrating diffusion in gases, why is it that the place should be an enclosed area? You have to prove and give for an example. So I will let's start closing the windows and doors now. So this is our material. This is our perfume. This is our going to use. So some of us also close the door. And on our solar so that there will be light here. Oh, close it.
Kevin.
And point two says that, oh, close it. Close it.
Sir. Sir.
Got it. Go ahead. On the solar in the page block wax. I hope you know where it is. Got it. No, go to the engine. Ask madam to on the solar for you. Then point two says that you do what? You have to do spray the perfume at what? At one corner of what? The classroom. So point two. Okay, so now our solar is going to be light. So you follow to go to the other end of the classroom and get enough spray there. So we are going to observe what will happen.
Let's
Oh, straight enough as you can. Blessing, it's okay. It's okay. Now, let's go. You see, you are suffering. Blessing is suffering because yes, she's suffering serious. There is high concentration of perfume. So now, blessing has moved. So the perfume being sprayed at one corner. Let's wait for Emefa, Akupaka, and the rest for some time. Go there. What's happening? Careful, let's see that you have a problem. Yes. Aha. You look at this one. You know why that? Hello. You know why that means? There is high concentration. So diffusion, the movement of molecules from a region of higher concentration to a region of the other way, there is no concentration. Hello? Hello? Let's go for ourselves. So that's what we're going to do. So that I down. This fast, keep fast. So this is diffusion. So I'm thinking, it is who makes more about that who has prayer. I bet you won't come up. The more you go, the more you walk, then diffusion in food, in justice, not a hope. In the weakness of blessing, oh, come on, hey, the spirit of the blessing. Now it shows you that there is what diffusion from a region of higher concentration of molecules to a region of lower concentration. It is kindly of our solar. Because that's a good way of conserving energy and inform our energy transformation and conservation of energy. I told you that we need to conserve our solar energy. Good. So then what do we observe? So our observation. Uh, yes, someone to tell us what happened. The observation. What did you observe? Yes. The scent of the perfume. It did what? At first, okay, yes. Well, blessing. Okay, okay. What is it? Good, yes. Any other? Yes. So that's from one region to what? The other. From one place to what? To the other. Okay, so it was observed that after some time, the scent of the perfume spread throughout the classroom. Then our conclusion. Let's conclude. It can be concluded that diffusion really occurs in what? In gases. So it could be concluded that occurs in liquid. Oh, this is gases. Sorry, in gases. Any question? Any question? Right. Sorry, what's happening? Say that way. Say that. So our next activity is that we are going to demonstrate diffusion in liquid. So demonstrating diffusion in liquid. So our aim of the experiment. So experiment number 2. So an experiment to demonstrate diffusion in what? In liquids. So what are the materials that we will need? Materials. And in this case, we are going to use the liquid that we call the universal solvent. Now, which liquid is known as the universal solvent? Which liquid? There is a liquid we normally call the universal solvent. Liquid there. Hello? Hello? Are we here? Last time we learned about the topic water. Do you remember that topic? And we came across a liquid, and we said that liquid is known as a universal solvent. Last 2 terms, we learned about the topic mixtures. Do you remember that topic? The kaka in the one that's a seven tray. We learned about solute and solvent. We learned about concentrated solution, the types of solution. So, which liquid is known as the universal solvent? And the last topic we said that it is known as the universal solvent because it can dissolve wide range of substances. It removes a lot of substances. It's the liquid there. Sorry. Potassium. Potassium permanganate is a solid. It's a solid. Stop it. So, potassium permanganate is not a solvent. It's rather a solid. Have you forgotten this? And then we say that water is the universal solvent. And the water has the capacity to dissolve the potassium permanganate that we call the blue group. That's what it's blue. So we will need water. We will need what?
Water.
What again? We will need a beaker or any container at all. So let's say beaker. Then what again? Then the potassium permanganate itself, or any ink at all, good. But in this case, we are going to use the potassium permanganate because that's too common. So let's check our procedure. Now, I will perform the first activity, then you will perform the other activity. So, this is my beaker, it's an improvised one. Don't have my beaker. This is my beaker. So, first point, I have to half fill my beaker with what? With water. So, this is it. So, the first fill, half fill. The beaker with water. I said I will do the first one, then the various groups will also do same. So I am half filling the beaker. Good. And the second point says that I have to drop a small portion or a small crystal of what? Potassium permanganate in what? In the half-filled what? Beaker or water or not? Beaker. Good. So drop a small crystal of potassium permanganate into the beaker containing what? Water. Do you remember?
Yes.
Good. So this is the potassium permanganate. How do you all see that? That's the potassium. We don't call it potassium permanganate. So when this says that you have to drop a small crystal, so I'm about dropping a small what? Crystal. You can see that. How we can see that?
Yes.
So it's moved from a region of higher concentration to a region of what? Lower what? Concentration. So it has all moved down, and at a point in time, it is going to mix all together evenly. That's what we said until a uniform mixture is what is obtained. So we have to leave the beaker or the water to stand for some time. And I hope you can all see clearly. Let's add some other portion, at least some half of the crystal, and check. You see that it will be going down, it will be going down, it will be going down. So that's diffusion for us. Now this is what we're going to do. Abubakar's group will come and inspect. Omabaka said, indeed, sir, a blue, I say blue. Hey, your eye is like mine, you can't see from afar. So you have to come closer. Oh, so you can see it. Also, it has all time blue. Look at it. That's it. Can you see? Who's that thing that see? So with time, it will be dissolving. It will be dissolving. it will dissolve until there is a uniform what? Mixture. Hello? Hello? So, if you remember last time, we said something. And last week, you remember that we said we learned that there are factors that affect the rate of diffusion. And we said what? Stirring. Do you remember? So by stirring, you see it's mixing. It's mixing until a uniform mixture is obtained. Let's look at this. Now, without stirring, if you wash your white clothes and you want to get some, you want to apply the potassium permanganate so that it will feel so good and nice. And you didn't stir, what happens? Yes, what happens? Give to us. It will stain your clothes. We see at a picture here, we say, no, we should do that. Now, the one called the potassium permanganate. I said, where do you want? What do you do? What kind of liver? So that's that. The better can be. That's what we call diffusion. Any question? Any question? Good. Then, if no question, then one person from this group, one person from this side, and one person from this side, ever come forward and demonstrate this process. Oh, then I will need another person from each of the group to come and have film for them. To pressure, have the piece. First your body is first there. What you use this one. Yes, one person for the group. Yes, let's group one person. Yes. So let's let the house. Please do learn, give me learn. Please stand well. Blessed. Let your member be here. And then Asayori and Gifty's group. Hey, wisdom's group, my name. That's my name. So I just told you, okay, I think that's okay. So you pick it, then you drop and give it to your colleagues to do same. So it's what? So it's okay.
Jerry. Hey, Jerry. Jerry. Hey. Hey, Jerry.
I said, yeah.
So, no, stand in front of your group so that we have a look at what's going on. So, we could tell us, come and do yourself. Wow. So, Place the beaker on the table for it to rest for some time. So, you have to leave the mixture. Please carry it down and leave leaders. Please carry it down in the place. Or those who came forward. No, let me use those who came forward. Those who came forward. So leave the mixture for about say 20 minutes. For about 5 minutes. Then we observe what happens. Okay, let's go around and check. Let's check that on gifties group. Okay, there's still a mixture is still mixing. Not all that 100% mixed. Let's check that on wisdom. Not that bad. Still mixing. You know why? They didn't apply enough of the crystal. They just got a tiny drop. Check that of blessing is still mixing and still. So movement of molecules from a region of higher concentration to a region of lower concentration. Then let's check that of Clarissa. Good, still mixing. So still we still have higher concentration here and we have a lower concentration there. Finally, as I don't recording. So until a uniform mixture is obtained, please come for yourself. Can you pour the water or can you pour anything else? So we are going to take the last experiment.
Oh.
Hey. What?
Wisdom. Oh, yeah, yes. Excuse me.
Now we are going to take the final experiment. The final experiment. Hello. We are going to look at the factors that affect diffusion. Factors that affect diffusion. Now, we are going to look at the factors. Which say factors? The things that affect diffusion either positively or negatively. Things that aids diffusion to occur faster or to occur at a lower rate. Anything that helps diffusion to occur is what we call the factors. Now, the first one we're going to look at is the state of matter. How many states of matter do we have? 3. And if I name one, you want to highlight? Sit well. Sit well. Dogging. One state of matter. Hey, from what? The state of matter is from what? As how many? One thing around. Yes, Sylvester. Hi. Sorry. Hey. Sylvester, you give magic in our room. Right? We have done the magic. Yes, you know. Gas, five liquid. So we have the solid, liquid, and water. The gas. Now, let's look at something. Let's look at something. This is what? Perfume. Is this solid, liquid, or gas? Liquid, right? But if we spray that, is this still liquid? No, gas. It becomes what you call vapor. Hello? It becomes vapor. Now, with the state of matter, gases normally diffuse faster. Inflammation, straight. So, if you look at the state of matter, gases diffuses what? Faster. As compared to the liquid. Liquid will also diffuse faster than that of what? The solid. So if, example, I have this naphthalene ball, the one we call camphor, or I have the solid form or the stony form of the potassium permanganate. If we are to diffuse this, you got to know that it will take some time before it will be what? Diffused. Let's do that and check. Now, I have this. Let me add some water. Let me use a different container for that. Why a different container? Because there are some crystal of potassium permanganate in it. So, if you are to leave this, it will take a lot of time before it will be dissolved or before it will diffuse. Yes, a giant going up to man. A better answer available. A better. Why? I didn't see a better answer. Yes, 50. Because it is solid. Hello. Hello. Now, it is solid though. We also have the powder form, which is also solid. But you will see that the powder form will diffuse faster as compared to what? As compared to what? The stony what? Fine, or the stony form. Also, we can say the size of the molecule, the size, they can see it, and then send it. Now, this size, we are going to talk about how the particle is. For example, we have solid, but we have grinded this one into the powder form. Hello? We have grinded this one into the what? The powdery form. So if we are to check how the faster or how this will be able to diffuse or how these two will be able to dissolve depends on the size of what? The particle. So So the smaller the size of the particle or the molecule, then the higher the rate of diffusion. Let's put it there. I take it again. The higher or the smaller the size of the molecule, the faster the rate of what? Diffusion. So let's check. We have the powdery form here. It is so small. If we are to go back to JHS1, then we are going to say this is an atom because it is the smallest form of the potassium permanganate. We just grounded it and it became what? Powdery. So if we use the two, each one will be able to diffuse faster. The powdery one. Now, I still have the stony one in. You see, it's dissolving. Let's take it around. Hope you can see it's dissolving. And hold on. You can see the moon say there are crystals there. Like I said, hold on. You can see that. Now check the time we place this stony one into this particular solution. Now still a moon year. You see, you know, say a follow. Now, let's put it aside. Let's place it here. We get another solution using the powdery or the powder form of the potassium permanganate. The intervention every day. Now, to tell us the size of what the molecule. So this is the potassium permanganate. I'm placing there. I've placed it in. Then another portion of the powdery form. Good. You can see it has started dissolving. Can you see? Yes. Please, those that can you see? Good. So it has started diffusing. So from a region of higher concentration to a region of what? Lower concentration. So let me get my powdery. So let's leave the two to stand for a while. Then we will be able to arrange. Now check. Look at the powdery one on my right and the solid one or the stony one on my left. You could see the clear difference. So within some few seconds, diffusion has taken place. And look at this. So that tells us the size of what the molecule. Now, let's look at temperature. What is temperature? What is temperature? What is temperature? What is temperature? Yes, Gifty, I saw your hand up. Yes, what is temperature? Okay, you get it from today. I will teach you temperature and I will teach you heat, and we are going to look at the effect of heat and temperature on substances. Now, we have this effect. People say temperature not high, temperature is this and that. What comes to mind simply means that there has been a change from either a cold portion to a warm portion and to the hot portion. And the again, that is another state or form of temperature. Say, again, you do the lukewarm, also another form of temperature. And so again, it also forms another form of temperature. Now, whenever we visit the clinic on a chip compound, the nurse normally brings something at our outlet to check something. The nurse is just checking the temperature of our body. The higher the temperature of the body, the bigger there is an abnormality. Now, the lower the temperature, also, the never get it. Now, and the instrument that is used to measure temperature is called thermometer. So, from the inception of COVID-19, schools started using the thermometer gun. Hello. So whenever I want to go, whenever I come to class, we just point the thermometer gun at the forehead and the distance, and it will record what the temperature for us. So what we are trying to say is that the temperature also helps. Look at this one. Look at this one. Now you can see that it has almost dissolved. There's 21. Now look at the two. Look at the two. Now let's look at something. Let's turn and look at something. I have a portion of good. Let me go. Good. You see? I hope you can see the difference. That's it. So that's the clear difference in the size of the molecule. Okay, come on, point away from me. Then let's change. Let's I'm going to take this one. Then when you take this one and point away, so that we can get another. Now we have our hot water or our warm water, and we are just changing the temperature of the liquid that we have here. This liquid is water. Now I want you to feel it. Oh, put your hand in. Is it hot or cold? Cold. Hey, you answer. Hey, okay. So we are going to use this one. The cold water, there are still some portions of crystals in it. Okay, now again. So you see the water vapor. So it means that we have changed the temperature of what? Of this liquid. Of this liquid, which is the water. So let me pour a portion to wash or to get off the dirt, and I will do that. So I'm getting the warm water to clear off. Good. Hello. Now I am going to we are going to use the naphthalene or the camphor balls for this experiment, looking at the temperature of it. So let me pour a portion of the cold water and then let me pour a portion of the warm water. Please, let's take this one, the cold water, and this one, the warm water. So let me place it side by side so that to be able to good. So I have two naphthalene balls. Hello, and I'm placing it simultaneously in it. Let's leave it for some time and check what will happen. The one that will dissolve fast and the one that will not dissolve fast. Then, in doing so, let's get this done. We are going to use the potassium permanganate tube, the stony one, to get the same experiment done. So this is what I'm going to do. I'm going to measure the hot water using it so that we get a uniform or the same volume or quantity. So let's look at the size where it is. Let me mark it. Let's mark it. So on this side, then I'll pour it here. And then I'll use the cold water. I'll measure the same quantity of cold water. To that same volume. Then I'll come, let's say, come and go, yes, 50 come. So you are going to use this, and you are also going to use this. And let's look at the weight. Let's make it the same time. Wait. Let's make it the same time. Let's wait until blessing is done with hers. Okay, good. Now, I want us to do another thing as we wait for this experiment to take place. Now, I have another naphthalene ball here. I want to place it into this and let's check something. Oh, we will wait. We will come around and check for what happened. So we are just changing the temperature of the liquid. So we will then inspect after some few time. We will let the mixture, we will leave it to boil. Then we get to know what's going to happen because of the change in temperature. Then we can also do so by stirring, and we did the stirring already. So stirring. Okay, can we see it? So is there any after ball in it? Oh no. Can you see? Okay, now let's check the cold water. This is the cold water. So by just changing the temperature of it. Oh, okay. Someone will say, I just remove the naphthalene ball from it. No problem. Let's put another naphthalene ball in and let's check. Please, can you all see the naphthalene ball?
Yes.
Please, all of you come around so that we can have a picture. Please, let's do. So, even if I pour the cold one in, let's look at the quantity of water I have. Please, you can capture this one. You see the quantity of water we have here, and you have enough talent board in it. And look at the quantity of water here. You see, it's dissolving. You see, it's dissolving. What's that? It is liquid. That's it. So temperature can also assist or affect the rate of what? Diffusion. Count for yourselves. Let's go. Please sit down. Sit down. Sit down. Finally, we have come to the end of diffusion. In our next meeting, we are going to look at osmosis. And in this topic, we have learned about diffusion of the. Hello. Let me find evidence. There is an evidence. Is it not right? Now, when we start the set off, then after we go, that's diffusion. That's diffusion. If you learn about the definition of diffusion, you have taken an experiment to demonstrate diffusion in liquid and diffusion in what? Gases. You have also taken a lot of response on the factors that affect diffusion. Take your exercise book and let's do this. So exercise number basic from exercise number 16. 16. So you have to define diffusion in your own words, not in my words. In your own words. And question two, you have to state three factors that affect the rate of diffusion. Thank you very much and have a nice day.